Okay, with this one I want to do a few tech tool demos. So showing you what Wolfram Alpha, Symbolab, or Calcplot 3D can or can't do. So maybe let's go through, you have a couple tech tool pages with examples, and then there's a couple tough examples I worked through, and then a few practice ones for you with the D-test. Well, let's just go straight to a tech tool. Let's see what Wolfram Alpha can do. So I'll share the screen. Okay, so you can enter things like critical points of, what did we have? We're working on, what's that, 4x, or is x to the fourth maybe? Minus 4x cubed, was it? Plus 4x squared minus y squared. Okay, first of all, okay, so those are the same ones we found, and it always shows them, again, critical point in R3 as needing an x and a y component, which we have there. So we had 0, 0, 1, 0, and 2, 0, the 3 critical points. Sometimes for more complicated ones, though, it doesn't necessarily find them, or it'll tell you that it tried, but it couldn't get there. Symbolab does that a good bit too. Oh, while we're here too, you can also, instead of critical points, you could say find the saddle points. So in essence, then what it's doing is doing part of the D-test for you. And yeah, that checks what we did with the previous example, that the saddle point 0, 0 was a saddle point, 2, 0. It shows the surface, puts them out there. And you can see right here at this one at 0, 0, again, you could straddle your legs this way, and then this would be the little part that you're kind of holding there on as you're sitting in the saddle. So it is a min in this direction, a max in that direction. That's what makes the definition of saddle point. Same thing happens over here. And then this is the one, 1, 0. We didn't ask it to find local max, but it would be right here. And that was the one that is the peak at 1, 0. So you can also say local extrema, and it should find the local max. Oh, so it looks like there is a Extrema calculator of several variables. Oh yeah, it wants to know whether you want to maximize or minimize. So you have to be careful about your language and vocabulary here. And let me show you quickly Symbolab. I think we can type things like critical points. Yeah. And I think we can do higher dimensional functions. So we'll take their example and modify it. Let's say we had x cubed times y. So this one doesn't support multiple functions at this time. I think there are ways that you can get derivatives and partial derivatives, and second order ones. It does have some, there's some multivariable calculus. And here's some examples of things that it can do with multivariable calculus. So you can take these kind of partials, which again, you're going to need when you do the D-test. One thing that's nice, so Symbolab is a little bit more limited, but one thing that is nice is it can, for the problems that it can do, which again, not as many that a lot of times it'll come back and say, beyond my capability, just can't do that. But the ones that it can do, you can show the steps. So hide steps, show steps. And it'll talk you through like which things are treated as a constant. They get pulled out, and then you're really just taking the partial with respect to x, if x squared, y squared. And there are more practice problems. So this is a good tool to show you if you're really having trouble doing the partial differentiation. This is a good tool. Okay, and then we've already talked about Calcplot 3D I want to show you one more thing about Calplot 3D. So you know how to put the functions in and change rotate the view and see what they look like. And this one's not going to be a calculator or calculate partials for you. So we'll just use this preset function that they have. Remember Lane's tip, we can use the arrow keys on the keyboard. It gives you a little more control over looking at the surface. And by rotating it, we can see some things like, okay, it looks like right here is a local max that may also be a global max. Same thing here, they look like they're probably going to tie along the z-axis in height, so maybe we have a tie for the global max. Local mins, which are also probably global mins, and then maybe at 0 here, looks like there's a chance that could be a saddle point. So lots of stuff happening on the surface, but I want to point out one thing about the contour maps. We've already done contour maps in Calplot 3D. So let's ask it to do that from, say, -2. Let's get 15 contours. Let's see what happens, create the plot. Okay, so again, it has this shape here. And one thing you can notice, you can actually get your local extrema information. There's a couple nice pages in your journals about this, but you can get local extrema information from the contour map as well. So you can get a good hint. Even if you were having trouble maybe cranking through on the algebra that we've done on whiteboard on your notebook, getting your partials, getting your d-test, and you want to verify this, you can visually verify it the way we just did in Calplot 3D. Another visual verification is that the contour map gives you information about local extrema. And this should be apparent that as your rings are getting closer and closer to a point right here, that point, so we can look at the contour slicing through like an egg slicer, or like I always think like Wolverine hands, like right, slicing through. They're making the contour map. This point right here is a point on the surface. Oh, it's down over here. And it turns out it's a local min. And how could you tell that from the contour map? Well, again, these rings, these concentric rings, getting closer and closer to a valley or a peak, and you just have to decide, is it a valley or a peak? And you get that by reading these little numbers on the contours. Remember, those are height values, z equals values. And so they're getting more and more negative. I'm going from -0.6, -0.8, all the way down to the center of -1.2, and then at this point, it's even lower than that. Oh, here's the value right there. So if you look up on the green bar or inside this blue here, it's showing you that the height is at like -1.3-ish, roughly, down here on the surface. So that is a local min. And on the other hand, this point over here, turns out again from the contour map, I know it's either a min or a max because those rings are getting closer and closer, smaller and smaller, either coming to a peak or in the other direction, smaller and smaller, going down into a valley. So this point here, you can tell is a max. It's a local max. It's got to be bigger than its neighbors because the z values as you get closer to that point are ascending. And it's local because we're not sure, we haven't learned a method near. If I'm at that point and I look all the way around, am I actually bigger than everybody on this graph? We don't know a method for doing that. That's the next section of this chapter in the next set of videos. Oh, one last thing, so saddle points. Saddle points look like, let's put in that surface that we had instead of this preset one. So let's change to, we had, previous example was x to the 4th minus 4x cubed plus 4x squared minus y squared. So let's look at this surface. And let's use our arrow keys a little bit better. So yeah, we've got this, there's that one peak, local max, then there's a saddle point down in here, right? So, and then it really ascends this back wall steeply. It looks like something else is happening over here, over at 2x, x equals 2, y equals 0, which was what we also, our calculations had borne out. So I just need to change the range though, because I'm only looking at restricted part here. So I'm going to go down here and say I want to go from -4 to 4, maybe -4 to 4, and let's see what happens. I think some of it get really, but yeah, these two walls get really big. So maybe ask for more grid lines to smooth it out a bit. 60 of them, okay. And as we move around the surface, again, saddle point, those are the ones that we found. whoops, I wanted to move the points. So that's, let's do another contour point because that's the old contour point still showing. So create the plot. Right, so here we are now. And on this contour plot, there it is with our slices. And now we're over here at the contour plot in the 2D part. And you can see it here in 3D. At 1, 0, we have these concentric rings. And they would be rising up. It's hard to see the z equals k values, the way the computers put them really tightly over there. But we know from the visual here that that was a local max. So at 1, 0 is a local max. We know that checks our algebra with the d-test. But what do those saddle points look like? It turns out that saddle points on a contour map are like little x's, right? So at 0, 0 is a saddle point. We saw that visually over here. When we kept pivoting this thing around, there we go, it's a better view. We see our saddle point there at the origin, 0, 0, one over here at 2, 0. And that's what shows up also on the contour map as x's. Think about why that makes sense, because again, here's a place where I'm like putting my legs, and then here's the place where I'm grabbing that part of the saddle to hold on. So x's, saddle points, converging to a point, concentric rings, either max or min. And then you determine whether it's a max or min from reading the z values. All right, so have fun with the tech tools to verify your work.